Welcome to today's seminar arranged by Swedsoft Industrial Open Source Network, that is a member network within Swedsoft. My name is Tricia Holmqvist and I'm an industry coordinator at Swedsoft. Swedsoft is an independent non-profit organization and we work with members from different areas of Swedish software such as academia, industry and organizations. Our mission is to increase the competitiveness of Swedish software. In Swedsoft, we work with the focus areas, education, and how to get more people involved in software development and research, as well as the area research and innovation. In Swedsoft, we work with influencing, collaboration, and things that we do ourselves. For influencing, one example is that we work with kompetensutvisningar to prevent that people with the needed skill and employment are not forced to leave Sweden. We also do reports and comment letters to the government and such. We collaborate within different forums connected to Swedish software. We do, for example, statistics with Statistics Sweden, conferences and events and such. I'm looking forward to today's seminar and feel free to contact us at Swedsoft if you have any question so we can tell you more about Swedsoft and the possibility to become a member. Now I hand over to Nicholas, who will tell you more about today's seminar.
So hi and welcome to Industrial Open Source Network. And again, as stated, it is a free network and where everyone can participate. We are encouraged, of course, everyone to consider being part of Swedsoft like ourselves. And the purpose of the network is to exchange experience and knowledge in open source. We have had a couple of physical meetings talking about different aspects related to open source. And now we thought of running some webinars during this time. So last week we had webinar around OpenChain, and this week we will have a webinar around software security and vulnerabilities. So today we will have three speakers. We will have Martin Hell from LTH talking about software security maturity models. We will have Stefan Andersson from Axis describing some of their experiences, and Emil Wåreus from Debricked will end with some of the challenges in actually then using machine learning to be better to describe vulnerabilities. At the end, we will have a brief or a short Q&A session that I will handle. So there you can state in the comment section what you would ask our speakers about. But our first speaker is Martin Hell from LTH. Please, Martin.
Thank you, Niklas. As Nicholas mentioned, I'm going to talk about maturity models and a link to open source security. The goal of this presentation is to first give a short overview of two of the most well-known software security maturity models. And then after that, I will also describe a little bit about our work on maturity models that we have done at the university, which is focusing on handling vulnerabilities in open source software. So just first trying to briefly define what is a maturity model, so you can say that this is a tool to help organizations assess and improve the way that they work. So the maturity model here can be used as a tool to identify your different areas for improvement in the specific domain that you are looking at. And today I will specifically, of course, look at software and software security. So what you can do with this maturity model is then you can see if you are missing something very fundamental in your initiatives, and you can help also improving the specific initiatives that you are taking. And the maturity model can then also help prioritizing how you want to work with it and what you want to do first and what you want to focus your resources on. One thing that comes to mind when you start talking about security models is who will determine what is the right things to do, and also what will define your maturity. And I will look very briefly on the two, for sure, most well-known maturity models for software security or software assurance. And these are the BSIM and the OWASP-SAM models. Both these models are very similar in the sense that they are trying to help organizations to have better work around their software security, but they are also very fundamentally different in how they try to achieve this. And I will try to highlight these differences between the two models. So the BC model, which is now in the 10th iteration, can be seen to be a descriptive model. And descriptive here in the sense that it is a data-driven model, which is based on the actual activities that are going on in more than 100 firms. So what they are doing here is that they are interviewing different firms, asking them what they are doing in software security, and then they are reporting that. So they don't tell you what to do in security. So instead they say, what are other people doing? So they just observe and report. And the rationale behind this is that if other firms are doing this, and if many firms are doing it, then it is probably a good idea for you to do it as well. The SAM model, on the other hand, can be seen as a prescriptive model. And prescriptive in the sense that this is a community-driven effort where experts suggest the best practices that you should follow. So it doesn't report on what is actually going on in the industry, but it's still saying, well, this is what you should do in order to have good software security in your organization. So this can be seen as general guidelines of what you should do in your organization. So just briefly looking at the framework for the BC models, what they do is that they divide it into 4 different domains that covers a broad spectrum of how you should work with software security. So they span from the first domain is governance, which means that how you organize, manage, and how you measure your software security initiatives. Then you have the intelligence domain, which means that you collect corporate knowledge about, in particular, the software artifacts that you're going to build. And then you have the SSDL touchpoints, which focuses much more on the actual implementation and the actual software. And then you have deployment, which will focus on the surrounding environment around your software and the deployment of your software. If you look at one example here, so now we look at one example, which is domain governance and practice training. So what they do is that they have a set of activities. So under training, they in this case have 12 different activities that they ask firms, are you doing this activity or not? And then you can see what is the ratio of the different firms that are doing this activity. So if we just take the first as an example, conduct awareness training, what BSIM does is that they give you an overview of this activity, what you should think about when you implement this activity in your firm so you don't miss anything essential. The maturity level here is actually given by the number of firms that are doing this activity. So this doesn't say that you should do this or that it is a good thing to do. They just measure, well, there are quite many firms doing this, and if there are many firms doing it, then it reaches level 1 in maturity. If there are somewhat fewer, they reach level 2, and if there are few firms in this survey that are doing this activity, they reach level 3. So the levels here can not only be seen as a maturity level, it can also be seen just as how common is it to do this activity in industry. If we instead compare this to the OWASP SAM maturity model, they have a very similar framework where they divide it into so-called business functions instead of domains that they had in the BSIM, but it is very similar to BSIM. They have 5 different business functions. The first one is governance, which is basically exactly the same as BSIM, and then they divide the rest into design, implementation, verification, and operations. But in many senses, these are very similar. So if you look at the practices here, you can, in many cases, map the practices almost directly to the practices that you have in the OWASP, in the BC model. It gets more interesting, however, when you start looking at the levels of maturity in the SAM model. So if we take the same business function that we had before, so we have governance and we have the practice that here is called education and guidance. It was called training in the BSIM. Here they divide every practice into 2 different streams, and every stream has exactly 3 activities associated to it and 1 activity for each level. So in SAM here, what they are saying is that you can assess your maturity level in your organization by answering some assessment questions. So here instead, in BSIM, you had mostly yes or no questions. Do you do this activity or not? Here you have a little bit more nuanced view for the questions that you can answer, and then you can make a self-assessment based on this. And here they also, kind of similar to the BSIM, they define quality criteria. So what should you do in this activity in order to reach a specific level? And then the levels here are much more progressive than they are in the BSIM model, where they have more or less separated activities. Here the level 2 activity clearly builds on the level 1 activity. So now when you have these models, what should you do with them? Well, I think one thing that is very important to understand is that these models are very generally described. They should fit both small, medium, and large organizations. They should also fit any development styles. So if you have waterfall or agile development styles in your organization, it should still fit into the maturity model. And they should also fit different types of companies working in different domains. So this one size fits all can be seen as a strength because you have one model that you can go to, or in this case, two models if you want to choose between them. But you can also see it a little bit as a weakness. And a weakness in the sense that, well, just exactly following the model doesn't necessarily be the best thing for your company. So you should think here, you should not put the same effort into all activities. Some activities are more important for your companies than other activities. And also you don't need to think that you should finish all level 1 activities before you move on to the level 2 activities, because in some companies, level 3 activities might be more important in some domains than level 1 activities in other domains. So the maturity models here should instead be used to understand and assess the current activities in your organizations. They should be used to help you define your own target and define how you should reach your goals in your organizations. But the width of the models are very good for reaching a balance between the different activities. So they should be used as a help, but maybe not as a blueprint of exactly how to do things. So I would just also briefly mention the maturity model that we have developed in Lund University, and we call this model HAVOSS, which stands for Handling Vulnerabilities in Third-Party Open Source Software. So the idea with this maturity model is to focus on managing vulnerabilities in third-party libraries and code, and all the practices that are related to this. And why do we want to do this? Well, we think that many organizations are using open source software. We see an increasing use of open source software in organizations, and this is for good reasons, because they significantly decreases the development time on your software, and also the software maintenance for the open source software can focus more on updating your software to new versions instead going in and making direct changes to the code. You just typically update to the new version. And here it is very efficient. Here it is very crucial to handle the OSS vulnerabilities efficiently, because when the vulnerabilities are known and they are posted online, they will apply to all the users of that library, and they will immediately be known to all people in the community, which means that exploits are quickly crafted, and you can see exploits in the wild rather soon after the vulnerabilities are known. At the same time, if you need to make urgent updates, these can be very costly for the organization, because if you need to make an out-of-cycle update, you maybe need to change the pipeline in your development, you need to refocus your resources to something else, and this can be a little bit disruptive in the organization, and it will be costly both in money and in time. Both the BSIM and SAM maturity models, they do recognize the use of open source software. So in BSIM, you have two activities that are directly related to identifying and controlling open source. And in SAM, you have a specific stream that is called software dependencies, where all the levels are related to open source software and to handle security in open source software. The point in HAVOSS is that we specifically intend to cover open source software vulnerabilities, which allows us to be a little bit broader in this domain, so we can have all the activities that support effective handling of OSS vulnerabilities, and we can at the same time be a little bit deeper, so we can have activities that handles different stages and considerations throughout the vulnerability lifetime. So this should not be seen as a replacement for the other maturity model, but more as a complement of them. So the methodology that we used when we developed this model was that we first interviewed a set of companies to understand the problem, and then we used other maturity models and saw what they were doing in open source security and specific guidelines for open source and other security guidelines, together with interviews to define an initial version of this model. And then we used the industry to help evaluate this initial version of the model using their qualitative experience from assessing their own organizations. So this gave us a final version of the model, which we in turn evaluated using various metrics, which I will briefly mention very soon. So in this model, we have 6 what we call capability areas. So the first capability area is product knowledge. So you need to have good knowledge of your product and your software artifacts in order to understand and evaluate vulnerabilities. Then for the specific vulnerabilities, you have a chain of events where you first need to identify the vulnerability, then you need to evaluate this vulnerability in the context of your organization and your products, then you need to remediate this, and then you need to deploy software updates, for example, deploying a new firmware, deploying a patch to the products or the software that you have. And through this chain of events, you also need to communicate. And this is both internal communication and external communication with, for example, security advisories, media, and, for example, important customers are included here. And for each of these capability areas, we include a set of practices. So here we have in total 21 practices divided into the different capability areas. Maturity levels that we are using are inspired by another maturity model, not BSIM and SAM in this case. So here we have something spanning from 0 to 4. So 4 means that we don't do this at all in our organization, while 4 means that we collect experience and metrics from our approach and we base improvements on that. And then you have 3 maturity levels in between. So we did 2 evaluations of this model. So the first evaluation was from the evaluatee's perspective. So here we asked 23 people from various companies what they think about the different practices that we have. So for each practice, we wanted to assess the importance of the practice, how important it was to actually do this, and then we also wanted to assess the importance for completeness. And by this we mean how important is it to have this practice in the model, because otherwise it could, for example, be neglected. The next evaluation that we did was from the evaluator's perspective. So here we took advantage of 2 teams within one company, and we actually tried to do a real assessment of the maturity according to our model with those teams. And the questions that we ask ourselves here are, how difficult is it in an organization to assess the maturity? Because if it is difficult to assess the maturity, it's also difficult to increase the maturity in these ways. So without going into more details here, I will just refer you to the publications that we have that are related to this maturity model. So this is done as joint work together with one PhD student, Pega and Martin Höst. And we have in total 2 publications related to this. So if you're interested, you can just ask me for the publications. And with that, I'm going to end, and thank you for listening.
Thank you, Martin. So we are now moving over to our second speaker, and we're going to have experiences from Axim presented by Stefan Andersson. So please, Stefan.
So thank you for that introduction. So Stefan Andersson, I am a security coach at Axis, which means that I spend all my days helping teams becoming better at developing secure software. A little bit of background on Axis and open source. So we did our first embedded Linux-based product in 1999, which means that we have had a long relationship with open source in general and with Linux in particular. It has even affected our organization and our culture. So a lot of our engineering culture is really inspired by the Linux community. So a lot of the things we do, even on internal development, kind of looks like what you would find in open source projects. So Martin was talking a little bit about security development models in general, and what we do is our own particular flavor called the Access Security Development Model, and basically the reason for having our own thing is really that you need to have something that's adjusted to your environment and your organization and even your culture. So if you look at the things we're doing, they are really resembling both BSIM and OpenSAM, where we have a set of activities spread across all phases of development. And although this model looks a little bit waterfally, it's not intended for a waterfall approach. It's basically a set of tools and techniques that teams can use in different phases of their development. So I'm a part of a team called Software Security Group, and we do most of the things related to governance. So we help the organization with training. We do a little bit of assessment on how the security work is actually progressing, and we try to gather metrics to follow up on the work as well. But everything else is done by the teams, and typically they start out real early by doing risk assessments already when they are doing their backlog grooming, so they have a chance of deciding how much security work is going to be spent on a particular feature they're developing. So basically the risk assessment practice really means that everything we do is kind of risk-based. So we're spending much more security effort on things that are considered high risk and much less security effort on things that are considered low risk. We're doing a lot of threat modeling, so we're trying to push security as early as we can, and doing security during design discussions is actually a really good way of injecting security early within the process of developing something. And it kind of looks like we have vulnerability management at the end. And that's kind of since it relates to stuff that we have deployed on the market. But in practice, that was the first thing we had to start out with. So typically when you build a security program in a company, you start out by forming it based on some catastrophic event. So it's quite common that you start with vulnerability management, related both to your own problems and potentially also to open source. So the approach we have taken is really team-centric. So it means that all security work done is done by the development teams. So everything we try to get done in the organization should be possible to do by the ordinary development teams. So we're kind of adding new tools and new skill sets to our developers and to our teams. And there are two reasons for taking that approach. So the first reason is really tightly coupled to our culture. And our culture is highly decentralized. So it means that all our development teams are essentially responsible for everything they do on their own, which means they can basically take all sorts of decisions without really getting approval from management, and that ranges all the way from decisions related to what they're actually developing to decisions related to their whole development pipeline. So it means if we would have tried to do something central and impose that on such a culture, it would never have worked. And then there is another reason, which is not specific to our culture, but is more related to modern software development in general, and that's the fact that we want to optimize throughput as much as possible when we're developing things. So we don't want to introduce any bottlenecks or delays or anything else that doesn't empower the team to be in control of their deliverables. So shipping code or components or products off to some other team that does the security evaluation on their behalf would introduce such bottlenecks, and we're really trying to avoid that. So for that reason, the team I'm in, we're actually super small. It's just 2 of us, and we are supporting in excess of 800 developers these days. But being a coach and mentor for 800 developers is kind of hard. So to our aid, we have a virtual team called Satellites, which are developers, architects that have a little bit extra interest in security, and they are embedded within the development teams, and they sort of represent security within that team and sort of remind the team and coach the team to do the right thing. And in our current setup, we are around 20-ish satellites, and that's been an absolutely excellent experience, because there's a lot of skill coming out of the satellite group. So implementing a security model in a organization, there are some things to consider. So the first thing to consider is, where do you start? Do you start with all the teams and all the code at once? It's pretty obvious that you can't do that. That's bound to fail. So the way we have done things is we started out by focusing on teaching teams how to develop more secure software, and we did that by introducing the security model for the new code that we're developing. So that's a much more pleasant environment to learn new things if you do that while you're actually working on some new things at the same time. And we spent quite an amount of time in that stage where we were just focusing on teaching teams, just focusing on the new code. But that doesn't mean that we were actually significantly increasing the security of our products. To do that, if you have a product that has some roots going back 20 years, you actually have to look at your legacy code as well. So these days we're also really trying to increase the product security by looking at high-risk legacy components. So we're basically going back in time and applying the whole toolbox for the Access Security Development Model for selected high-risk legacy components. So what about open source? So around 90% of our products are open source. So it means that in this approach, where we start out by new development and start out by analyzing high-risk components, we're still just focusing on the things we are developing in-house. So the natural next step is, of course, to get a grip of our open source dependencies and the security risks involved with those. And again, we're taking the same sort of risk-based approach, where we pick the components that are most exposed in our products, and we start paying a little bit more attention to security in those. So right now, it is the responsibility of the maintainers within the organization to keep the high-risk components up to date. And when we're doing threat modeling, it's also pretty obvious if we're bringing in some new open source component, whether it's high risk or not. Not really based on the security properties of the component itself, but really where we're going to put it in the system. So is it something that's going to be highly exposed and a part of a sensitive piece of our architecture, or is it going to be something that sits deep in the system without possibility to have great impact on the products? So when you want to bring in a new open source package, I would love to sort of know or measure the security of that open source package we're bringing in. And that turns out to be pretty hard. So what I would prefer to do is to actually understand the maturity of the open source project that developed this piece of code. It would be much easier to build trust in the code if we could trust the development community to produce high quality stuff from a security perspective. So having a BSIM or OpenSAM evaluation being a part of the project would have been a great thing. But that's kind of a dream. We don't get that. So instead, we have to look at whatever data sources we can. And typically, what we end up with is looking at historical vulnerabilities on that particular project. So you can make all sorts of arguments whether it's a good or a bad thing to have a lot of vulnerabilities. But in my experience, it's actually a good thing to have a project where people are reporting security vulnerabilities, because that's a good indicator that people are caring about this project from a security perspective, and that the project is also fixing a lot of security problems. So having high numbers is in some aspect, it's a good thing, because it indicates that security is being improved. Another thing I'm trying to look for when evaluating a open source project is to figure out whether they have clear communication paths regarding security vulnerabilities. So basically, do they have a security page where they tell people how to report vulnerabilities, where we can find the latest vulnerability information, where there are contacts, etc. That has turned out to be quite a good maturity indicator as well. But the whole field of assessing what components you should bring in based on their security properties, that's still difficult and a bit immature. Once we've brought in a project or a component, we need to keep it up to date. Because essentially what we should expect is that vulnerabilities are identified all the time, and they are fixed continuously in the new releases. So a challenge for us is really to understand what vulnerabilities are around, what versions are they fixed in, what versions are we using in which products, and have we updated. So typically, if you look at Apache in this slide, you can see sort of an even detection rate of around 10 issues per year. So that basically puts the pace on security updates for Apache. For OpenSSL, it was fairly low numbers for a long time, with a spike around 2014, which you could guess that's related to Heartbleed. So once people understood that there could be security vulnerabilities in a security library, people started paying attention and found a lot of other things to fix. GStreamer, which is a project that's quite central to us. We used it for our video streaming pipeline. There's not that much activity in that project, with a big spike around 2017. And my amateur analysis of that is that someone in the project or connected to the project got interested in fuzzing and did a lot of fuzzing for a weekend or so and filed filed a couple of bugs related to that. But basically, the challenge is, with a lot of open source dependencies, there's a lot of things you need to keep up to date. Okay, some final words. So as I started out this story, we were kind of focusing on new development. And then we expanded that to keep to making sure that our legacy components were in good shape. And through that to actually keeping our open source dependencies up to date. But once you reach that level, there is an interesting question, for instance, like for a project like GStreamer, where there seems to be not that much security activity in the open source project itself. It becomes sort of a strategic question. Should we, as a user of that project, actually start contributing by contributing our own security analysis capabilities? So potentially, if you have projects that are critical to you, and you worry about the security level of that project, the only way to fix it is by actually getting involved with the project and contributing your own skills and time for doing security analysis. And that was my my final slide. So handing over.
Thank you, Stefan. So now we move over to Emil, our third speaker, that will talk us through a little bit on the vulnerability aspects. So Emil, please.
Great. Can you all hear me? Great. Thanks for having me. So my name is Emil Wåreus. I'm from Debricked. We are a startup based in Malmö, and I will talk some about how we enrich vulnerability data with some machine learning methodology, and how we work with and how some challenges within that particular data. But for some history on our company, since it's not as well known as Axis, we were a spin-off from a research project based at Lund University, conducted by Martin Hell, that between 2015 and 18, where they were looking at the risks in open source and how you could reduce the risk by still leveraging the large benefits of open source. And in 2018, in May, Debricked was founded, and I joined in September the same year as one of the first employees. Currently, we are about 20 employees. We have raised about 23 million SEK in venture capital from VC firms such as Luminor and Brightly. We've closed our first customers as well, such as Kry and Advenica, and we're also a silver member in the Linux Foundation. But looking at open source, about 96% of companies that develop software use open source. And the penetration of open source in those companies are not as high as Axis, but it's still very high at 60% of line by line, if you look at the code base. And this, of course, varies between maturity of the company and industry. And looking at the risks associated with leveraging open source, we are working with three types of risks. We are looking at security vulnerability and broader security aspects of open source. But there's also a licensing and copyright risk when it comes to open source. For example, BWM had a license problem in one of their models, the i3 model, which forced them to open source all the software that were related to that particular car. But we're also looking at quality aspects at open source, such as community and vulnerability response quality aspects. But we'll be talking mostly about securities from now on. One of the largest sources of vulnerabilities is the National Vulnerability Database, NVD. It's a government-managed database by the US government, and it contains about 130,000 vulnerabilities as of today. These vulnerabilities cover about 50,000 software products. Those can be both proprietary software, such as Windows, but a lot of them is open source software, large to small projects. And this has a community dynamic where the community reports potential vulnerabilities to NVD, where they analyze those reports and publish new vulnerabilities if it is a new vulnerability. And just to compare this to other databases, GitHub has their own security advisory, but they have not reached that high level of amounts of vulnerabilities yet. They only have 4K open source vulnerabilities as of now. When working with vulnerabilities, you need to put that in an organizational process to actually include that in your DevOps to remediate and understand what vulnerabilities you have. As Martin mentioned, you usually identify the vulnerabilities through software composition analysis, where you find out what software and open source you're actually using in your proprietary software, and you map that towards known vulnerabilities and hook up your to those open databases such as NVD, and are presented with lists of vulnerabilities that you have in your software, and can analyze them and evaluate them to later assign and prioritize that to your developers so they can remediate those vulnerabilities, either through simply patching that open source, updating that open source software that you're using, or contributing back to solve that vulnerability in the open source software. If we need to go through some terminology before we go further into how we solved our specific challenge with this. There are two things we need to know. CVE is a common vulnerabilities and exposures. Is a unique identifier of a vulnerability, and is usually published by NVD and other CNA instances that are allowed to publish CVEs. Initially, a CVE is always published with a unique identifier, the CVE ID, a summary which describes the vulnerability. It's written by humans and for humans and it usually contains some parts of the vulnerable software product, the open source, and the version range that is vulnerable, together with a description and implications of that particular vulnerability. But NVD also links each CVE to one or more CPEs. These are common platform enumerations. And each platform is a software, a specific software, and that is uniquely identifiable by a vendor and a product. And each CPE also has a version range, so you can map each vulnerability to a version range of that software. This is what you hook up to when you want to automatically find what vulnerabilities you have in your software and map that towards your software composition analysis. And as we can see here, we have some software here, Xorg server, and it can actually easily be found here in the summary. And we can see that the version range also matches with before that particular version in the summary. But some other CPEs might be vulnerable out of the context that other CPEs are vulnerable. For this instance, Solaris might be using Xorg as an indirect dependency. But there are problems with this. This takes time to couple CVEs to CPEs. It actually takes quite a lot of time nowadays. Before 2015, this was done in 0 days. So it was instantly published. When a new CVE was disclosed, you could find out it was machine readable to find out what software is vulnerable. But from beyond 2018, it takes about 35 days to map each software vulnerability to a CPE. But the vulnerability is still disclosed with the summary, so a human can read it and find out what software is vulnerable, even though machines can't yet. But we can solve this because the summary is published at day 0 as well. So we just parse the summary to find out what software is vulnerable. Great. Let's say we could make a lexicon of past entered CPEs and software products and try to find if there are entries in the summary where we match the CPEs and the summary. Well, there are challenges with this because a lot of vulnerabilities cover really, really large softwares, and a lot of the new vulnerabilities are entered with new, smaller softwares, and a vulnerability might be entered for the first for a particular software for the first time. So it's the first vulnerability that particular software gets. And about 1% of all product that NVD covers have 40 or more vulnerabilities, so that's quite a small amount of the total coverage. And 60% of all new CVEs don't have that. One of the CPEs that are linked to that CVE has never been seen in the database before. So 60% of CVEs cover new software. So we can't simply use a lexicon. We need to somewhat contextually extract what the product, vendor, and version is. So at Debricked, we have implemented a machine learning model that uses a task called named entity recognition, which looks and labels and classifies each word in the summary, whether it should belong to the product class, the vendor class, or a type of version range class. And as you can see from, this is the same text as the previous example, is the part of it. We have labeled this with X or product and server as product as well. The B and I annotation stands for that they are joint product word, so they are one product actually. And then we'll manage to figure out that this version is actually a version and excluding and not that particular version. This is computed contextually that we have the word before that over there. So what we have done is that we have built a large neural network to perform this task. The architecture here itself is not something new, but the feature engineering in this particular problem and using this methodology to solve this task is completely new. And we actually get quite good results in terms of how we're able to automate this. So in 0 days, instead of 35 days, we managed to find 88% of all products, 84% of all versions. And if we look at our last metric now, that I'm going to present, we have created a human comparison metric where in how many of the cases can we completely replace the analysis conducted by NVD and other CNAs. And that is quite high as well. So for 68%, we label the CVs with the product and vendor and version completely correct. And there's no further analysis needed in terms of assigning CPEs to that CV. But of course, humans have a lot higher accuracy here, but this gives us an estimate of what software is vulnerable that then can be replaced with human analysis when they have the time and the means to perform that analysis. And this establishes a new state of the art, and we have a patent on this. And in 2 weeks, this will be presented at DIMVA, at the DIMVA conference as a research performed by me and Martin. What I really want, we went to a really, really specific problem here. But in the end, we have worked a lot with open source vulnerability management and risk management, and it is quite hard. It's technically very challenging. And things that we are looking at Debricked and want to try to solve is, are we disclosing all vulnerabilities, for example, if we look at open source? I've seen research that for some languages, such as JavaScript, they have a habit of silently patching vulnerabilities and not disclosing them publicly. So I've seen numbers that about only 20% of all vulnerabilities are disclosed for JavaScript. Are the disclosed vulnerabilities we find relevant? Do you actually use the vulnerable part of the software in your system? are questions we want to answer. But then there's the more process and team-oriented part of this, where how do you foster ownership from developers to actually perform the patching or updating the dependencies to solve those vulnerabilities. And we have we feel that the best software tool for this is the tool that you actually use, rather than the tool with the most vulnerabilities or the best data. So user-centric focus here is important. And to wrap things up, we want to go to a broader space to really maximize the leverage from open source and minimize the risk, so developers can keep moving forward in their own in their proprietary software and keep delivering their value to their customers. Thanks for listening. Hope you enjoyed my talk.
Thank you, Emil. So with that, we will have some 5 minutes time for Q&A. So drop some questions if you have in the chat. In the meantime, can I then ask Stefan if you, I mean, for your model, did you consider, have you applied BSIM or SAM to you to see what you apply and stuff, or since they, I mean, they, as you said, there are a lot of similarities, but have you applied BSIM or SAM to see to see where you are and to identify improvements, or can you elaborate on that?
Yeah, that's a great question. So coming into the initial planning phase, we actually used BSIM as a planning tool before we even started. So BSIM was used as inspiration for the whole access security development model. And then during the years we have worked with this, we have done internal evaluation, and actually this spring we did a formal evaluation with the BSIM team. So we actually have sort of taken it all the way from using it in planning to doing internal measurements, all the way to doing a real measurement with the BSIM team.
Okay, let's see if we have some more questions. I'll have one for Emil, then I will wait. What would you say being, if you look on scaling challenges, the amount that is used, is that something that you consider, or how would that be when you're considering your analysis?
Do you mean the amount of open source used?
Yes.
Yeah, so I think that is a hard challenge, because when you import a project, you usually get a lot of things that you import without knowing. For example, React has over 3,000 dependencies. If you not only lock into the software, but they use same dependencies, but different versions as well. So it gets very complex very fast. So I think you should always assume that this is a complex challenge, and at how deep do you want to go in your analysis?
Okay. Let's see if we have more. To Martin was then, what would be to your model that you have then been implemented? What would be the future steps? Are there some? What would be the coming extensions that you are considering? Are there any plans for that? Are you muted, Martin?
Sorry, no, I'm not.
Yeah, no worry.
Yeah. I think for the last evaluation that we did, where we actually tried to assess this model, it was done in a single company. It was done with rather narrow amount of people. And what we actually found out in that evaluation is that you really need to be quite many people involved when you're assessing your maturity in this. I don't think that is unique to our model. You had the same thing in BSIM and the same thing in SUN. You need to involve quite many people in the organization. So I think one future direction here would be to more clearly understand who in your organization needs to be involved, both when assessing the maturity, but also when working with these kind of questions. And I think Stefan made a really good point there, that what we are seeing in industry now is that many of these initiatives are engineering-led initiatives. And it is really important to make this bottom-up approach where you have this spread out inside the organization. And I think this is what we see in industry to a greater extent today.
All right. So with that, thank you all for these interesting talks. What will be done now is that it will be, if the technology is with us, it will be publicized on Swedsoft homepage. So feel free when it's done to spread it to people that might be, that you know has this interest in open source and security and vulnerabilities. We look forward. We'll see after the summer if we continue to do these kind of webinars, or if we will have the opportunity to meet again. We'll see how the Corona and COVID status is. But except for that, I wish you a very nice summer, and we'll be back with more interesting topics after the summer. So thank you all for listening in, and goodbye.